Welcome to the Angular Mountain View Meetup. My name is Stephen Fluin. I'm a developer advocate on the Angular team here at Google. A little tidbit for those of you who've been coming for a while. We used to meet over in the Tierra del Fuego room. Now we've started meeting here more often. The Angular team is actually in this building upstairs. So if they're late, they don't have a great excuse, except anyone that's working on Angular. So tonight we've got three fantastic speakers. First up, we're going to be hearing from Graham, who's going to be telling us a little bit about Playground for Angular and the new version, the new exciting things that are going on there. We also have Playground for Angular t-shirts in the back. We have a very small selection, but if you're interested in one of those, definitely go take a look to see what we've got left there. Then we're going to be hearing from our buddy Alex Rickabaugh from the Angular team, who is going to be telling us a little bit about RxJS. He's got some exciting philosophies to share and really helping people adapt to kind of these newer ideas of how do we build applications better in a more maintainable, more awesome way than ever. And then finally, we will end up hearing from Jason Aden and maybe a special guest as well, all about building reusable libraries or packaging libraries for Angular, because we've given a lot of guidance for that in the past. We want to make sure that people are up to date with the kind of latest and best practices. We'll also be sharing a little bit about what's coming up with that in the future. So before we get started with this evening, I usually do a little bit of announcements about what's going on with Angular. But not a lot has happened in the last few months. So we released, I think, version 5.2 was the latest minor. We're continuing with our patches every week. And we've also started shipping now the first set of betas for version 6. This is always a really big news on things like Reddit and whatnot. And I'm always a little bit surprised by that, because how our betas and how our release cycle works is the moment we finish with the last minor in a release, so 5.2 in this case, basically you have a week of work that ends up shipping in the first beta for version 6. So not all of the amazing things that we hope to happen for 6 will already be in the betas. So you can check them out if you're really interested. We have everything we do is open source and on GitHub. So if you're interested in some of the kind of cool things that we're working on, they're all PRs that are in the repo, and you can take a look at yourself. But really, we intend for most people to kind of start taking a look at them closer to the end of the beta period as we're moving into RCs. That's where we're saying, hey, this is feature complete. We're reasonably confident that this is how it's going to look. So definitely stay tuned for all the cool things that we're working on to make Angular smaller, faster, easier to use. Any other announcements from anyone on the team? Oh. When will version 6 release? Yeah, so our goal is roughly to be doing a major release every 6 months, with each of those updates being very easy to adopt. And this is something that we spent a ton of time on with 4 and 5, and we're continuing to do with 6, is making sure that when we do require some sort of breaking change, we're helping developers with that. So the timing for that should be March, April-ish, but software is hard, so I will not make any promises tonight. Igor might make some promises. He's got a date in mind, and it's not my birthday this time, so sorry. And then Deborah, you had an announcement about an RxJS thing. Do you want to just mention it quick?
I'm one of the co-founders of the Bay.net user group, which mixes up Microsoft technologies with other technologies such as Angular. And we have one of our most entertaining speakers coming up. How many of you know Ward Bell? Couple? Yeah. He is incredibly entertaining, incredibly smart, and he is going to be speaking at our next meetup on Thursday, February 8th. His talk is on reactive extensions, specifically focused on observables. It will be at in Berkeley at Berkeley City College. We're on Meetup, so it's bay.net on Meetup, and you can sign up for it. Otherwise, if it's all right with you, I can post a link to it on this Meetup so that you can be able to click to it and register. It's free. Thanks.
Woohoo! So 2 more quick announcements. So for those of you who are relying on the shuttle, Mount MV Go, I think it comes at 8:20. So the talks will still be going on there, but the shuttle to Caltrain leaves at 8:20 if you need that. And then the last announcement that I have is that we are having another Angular Mountain View meetup on February 7th. So it's relatively soon after this one, but we are partnering again with the Modern Web Meetup. which we're really excited about, as well as the Google developer group Silicon Valley. So we're bringing in more content, more attendees, and we wanted to make sure that we're having frequent, lots of original content, lots of Angular team members presenting. So really excited for that meetup. Matthias, who I think might still be in the room, is going to be presenting on animations. So make your applications more usable, more engaging, better, and Matthias is going to lead the way with that. All right, with that, let me hand it over to Graham here, and we can get him set up.
Hello, everyone. Thank you, Stephen, for introducing and allowing me to speak. I'm going to be talking about front-end workflow. So with modern front-end frameworks, I've noticed a couple of things about how we traditionally approach constructing user interfaces and a couple of pain points with those approaches. So I'm going to discuss what those pain points are, and I'm also going to discuss a tool that we at SoCreate have developed free and open source to help overcome those pain points. So my name is Graham Marlow. I work at SoCreate. We're a small startup in San Luis Obispo doing screenwriting software. You can find me at mgmarlow on GitHub. And on GitHub, I will be posting, well, actually, it's already up there, but all the slides and code for this talk. So if you want to follow along, it's in the code directory, or afterwards, it's all there. So with that, we'll get started. I assume most people here, since this is an Angular meetup, are familiar with Angular and modern front-end tooling, things like React and Vue. But to give kind of a overview of some similarities in all these frameworks is they're all component-driven frameworks. So the user interfaces that we construct using these frameworks are created with these reusable components that are bundles of HTML, JavaScript, CSS. And although their approaches may differ individually, overall, you use those components to create your user interface. And this has been pretty great overall. Thinking in React published a great article, React published a great article called Thinking in React, which kind of outlines this component hierarchy idea. If you haven't read it, you should check it out. And it applies to all modern front-end frameworks and how all that stuff is put together. Oh, we good?
Thank you.
All right, cool. So the general idea of how user interfaces are constructed with this framework, which is what I see a lot of developers doing, be it Angular, Vue, React, is you start with a mock. You have either a Photoshop document or a drawn-out image of what your user interface is going to look like as a whole. Then with that mock, you break the UI into components. So you circle particular areas that component's going to live in. You start at the biggest level, and then you work your way down, breaking into smaller and smaller components. Then once you isolate what's called the component hierarchy, you build a static version with HTML. So you just do a markup rendition of it, no styles, no logic. And after the entire thing is built out and you have a static rendition of your user interface, you identify state. So how are these components connected? How are we going to develop logic? And how are we going to relate all these things to each other? And this works really well for smaller applications. This is definitely my go-to way and pattern of developing things. But the problem is, once we start getting into larger applications, there are a few issues. But here's what a mock would look like after we develop the component hierarchy. Each of the each of the different colored boxes are your different components. But you can see how the hierarchy is defined from what boxes encompass what other boxes. Now, the problem that I have with this particular framework is explained exactly by this slide. And I'll give you a couple of seconds to look it over. Right, but it basically demonstrates miscommunication, whether it be miscommunication between programmers, whether it be miscommunication just in the general management structure. The problem is we have an idea of what we want our user interface to look like. And that may be from the customer or maybe from project managers. And then we actually go and start developing that user interface and realize at the end, it's not at all what the customer wants, And typically that means we have to go back and redo it. Now, if the way that we designed that user interface had a lot of tightly bound data relationships, we're going to have to redo a lot of stuff. Now, how this ties into the React and Thinking React methodology is we have that entire state, that entire HTML built out before we can actually demonstrate something to the user. There's no logic in there. There's no representation of data. So if we wanted to provide a copy to give to a user to click around in it and see whether or not they like it, it's just not possible. So at the very end is when we finally have our demoable products and the user's using it and they realize at that point that they don't like it and we have to go all the way back. The ideal scenario is that rather than waiting till the very end to have a demoable product, we have it at every iteration. It's a lot like the agile methodology. So every component is demoable from the onset, allowing people to come in and mess around with it. And so we can get quick feedback and tailor our user interface to what the customer, what the user actually wants. Now at SoCreate, we've been throwing around this idea of scenario-driven development. And that's what I call that general methodology of quick feedback on components. The first two steps are the same as the React methodology. You start with a mock, you break it into a component hierarchy. I think that's pretty standard. It's a great way of thinking about things. However, rather than developing all of the markup, all of the HTML of the application, we start by building out every single component from the smallest piece up, right? So we don't have a structure of the entire component hierarchy. Rather, we just pick out the smallest component, whether it be like a row, and we develop it fully with all of its data, all of its relationships, and all of the logic that it needs. And that way we can demo it individually and get feedback on it, whether it's even just something so small that it's just color changes. And then you repeat this step until the entire UI is finished. And I see there being some distinct advantages here. One advantage is we have a fully demoable user interface at every step in development. Every component is fully built out as we're going along. That means that we can demonstrate it to a project manager or to a customer and get immediate feedback and have less churn at the end of the process when somebody decides they don't like how something looks. And to me, that's crucial in user interface development. Some other things are changes are easier, affect fewer components, because your changes are happening more often, they're happening sooner. And developing in this way tends to create more isolated and functional components. You can no longer just throw in a component because you have this big structure and say, all right, I'm assuming that this component has this data and has this many services and providers. It doesn't really work like that because that component is now isolated. You're working on that component and only that component. You might have an idea of what the component structure is going to look like, but you don't actually have it built out. You're just working on one component. And that typically means that your components are more functional in nature. They know what their inputs are, and they know what their outputs are going to be based off of those inputs. There is one problem with this scenario-driven development, right? And that's that how do we develop one component without the rest of the component structure being there, right? Luckily, we have some tools to help us out with that. Angular Playground is one such tool. So Angular Playground is a free and open source tool that you can use to help facilitate this scenario-driven development that I've been talking about. You can find it here at the website. But now I'm going to transition into a demo. So let me pull up here my other web page. Great. Looks pretty good. Maybe I can zoom in. Okay. So this is supposed to be a complex user interface, right? The idea is we have a set of steps that the user has to go through in order to reach this done state in which something happens. So if I were to test this, I would have to type in, my first, last, Marlow. Go to the next step, fill my age. Go to the next step. You get the idea. And then at the very end, we confirm it and we get our card, right? So this is a multi-step workflow to get to this card. Now, what if we want to add more iterations of this card and test them? Well, every single time we're going to have to go back, refresh, re-enter our data from start to finish. And it's a bit of a pain. So Angular Playground allows us to, instead of going through that workflow every time, we go directly to that component, right? So let me explain this a bit. But we have a drop down with the particular component that we're working on. In this case, it's called the collapse profile component. We can select it and have a card ready with the data provided to it automatically. And we can also switch to another card that has other data. We don't have to go through that workflow process. Now, this has a huge amount of power to it because it makes development on this particular component a lot easier. So I'm going to dive into the actual code behind here, and we're going to start with a very simple component. And I hope that I can do a split screen effect here. That works out pretty well. So my hello component here, actually, let me pull up this component. I'm going to search for hello component, basic. So my hello component here is just a simple component with inputs and outputs. Not a whole lot of complex stuff happening here. What Angular Playground allows us to do is create what's called a sandbox. So here I have hello component, which is just your standard production code, your actual component in the application. Now I'm going to go over to what's called the sandbox file. And this sandbox file, pull this over a bit. This sandbox file is actually what's bootstrapping that component so that you can work on it. Notice that I don't have to redefine the component here. I'm using the hello component directly. That means that any changes I make to the hello component are going to be immediately reflected in these sandbox scenarios. So here I'm creating a sandbox of the hello components being imported from that file because they live right next to each other. And we're going to add a scenario. In this case, it's called basic. So when you saw it in the search, we have lots of different options. This one's the basic option. So you can define whatever text that you want to be there. And we provided a template. In this case, it's just the most basic template that we can provide this component, which is a variable provided through the name. And you can see that right here. So let's get a little more complex. Angular Playground allows us to add context to these scenarios. So here I'm adding my own actual variable rather than just a hard-coded string to the template. And if we go look at that scenario with variable, it shows up. Here we're getting a little more complex. Instead of just having one component, we actually have more template markup. So a lot of power in Angular Playground is putting your own markup outside of just the component that you're working in. So here you can see I added a header and paragraph tag, and you can see that pops up immediately. So you can really stage your own scenarios rather than just components. Scenarios are multiple components put together into a particular fashion. You can even wire up outputs. So here's an example with outputs. It's got some more complex stuff going on in the templates. And it works a lot like how you would just define a regular component in Angular. And here we go to one with style, with color of red. So to give you an example of how easy it is to create one of these scenarios, I'm just going to take this code here, copy it, paste, and I'm going to make this with blue style and change the color here to blue. Give that a refresh, and let's look at the compilation. So this is actually using Angular CLI behind the scenes. It's using whatever compilation method that you want behind the scenes. In this example, I'm using Angular CLI, but it fits with whatever Webpack configuration that you have if you're using Webpack and not CLI. So going back to our example, we hit Control P, and here we have the example with blue style, and instantly we have that new scenario with our new markup. So it's really easy to create new scenarios for your components. So let's go back to this collapsed car example and work on a bug. So I'm going to go to the collapsed profile component sandbox. I have my two scenarios here, one which is above the age of 20, and I see this message over 20. And then the other one, which is below the age of 20, I see the message under 20. Well, what happens if you are exactly 20? Well, let's go ahead and copy and paste, create a new scenario, set our data to 20. Oops. Save it. Then Angular CLI is going to recompile, and it's going to refresh the page. We now have that new scenario available. Oh, I should probably rename it too. Exactly at 20. Here we go. Exact at 20. Great grammar. And as you can see, no message pops up. So that's a bug. I wonder why no message pops up. Let's go into collapse profile component. This is our production component that we're actually using in the application. And you can see here, well, you might be able to see here, I don't know. We have greater than 20, less than 20, but there's no equal to, right? So let's just make this quick fix here, less than or equal to 20, and we can say under or exactly 20. Save that file. Notice our playground is refreshing, and we'll have that change show up immediately with no other changes to the sandbox file. So this is the quick development cycle that Angular Playground allows you to undertake. You can stage whatever templates that you want and easily develop on an individual component, right? So with scenario-driven development in mind, this is how we're able to work on one component at a time without defining the rest of the hierarchy. Now, Angular Playground also has some other cool tools that you can use. For example, this is a documentation page containing 3 scenarios. So these are 3 material components that I developed separately from this. And these are just simply iframes. So you can imagine that this is just a page in your documentation system, and I'm including iframes for components in my application. So here I have one material component, and it's actually interactable. You know, I can search for California, select it. I can do whatever I need to do with that component, you know, and I can scale these iframes and style them, put them into different systems like Confluence if you're using a wiki, and have interactive documentation. Now, the great thing about this interactive documentation is because it's tied to your code base, all you have to do is rebuild it, and all of a sudden you've updated all of your documentation with all of your component changes. It's pretty powerful. We also have a whole suite of different configuration options. Here you can see a whole bunch of different, let me just go ahead and maximize this. You can see a whole bunch of different flags and scenarios. We have build tools so that you can do a test. Basically, it'll mount your components, open up Chromium and test whether or not there's any console errors, and you can automate that process and set up with builds. We have a whole lot of good stuff. And we also have now this demo.angularplayground.it, where we're going to be adding more material components so you can kind of play around with the playground sandboxes on your own and mess around. So feel free to go to that site and tinker with it. Yeah, that's all I had. So if anyone has any questions, I'd be happy to answer them.
About integrating this with unit testing? Can you do some automatic unit testing against these examples?
Well, so the unit testing, oh, sorry, what's up? Oh, he was asking, how can I integrate this with unit testing? So because you're using the production components already in the sandbox scenarios, you can just unit test those production components and have those run separately. But as far as testing your scenarios, we don't really have a way for you to do that currently. But we do have kind of more of an end-to-end test with the Chromium thing. So you can do a check errors. You can launch the components in your browser and have it check against those. But we just haven't configured an automated unit testing thing for that. Any other questions? Yes?
During the sort of development process, who's the main consumer? Like, it's really nice as a developer to see how we
So who's the main user base?
Yeah, I mean, who benefit from the most?
Okay, so the question was, who would benefit the most from this tool? This is really a development tool. So as you're developing your application and you're creating components, alongside those components, you're creating sandboxes. And that basically allows you so that in your workflow, like in this previous workflow I was showing here, when you're developing this app with this wizard in it, you can immediately develop every part of this wizard, including the card at the end, without having to go through this workflow process repeatedly. So we could go, for example, to these 3 variations of the collapsed profile card instantly, rather than having to traverse our application, step through a number of different screens to finally arrive there. Now, you could also use it for testing. So since the templates here are so versatile, if I pull up one of these, the hello component here, you can really add whatever markup that you want. You can also add whatever components you want. You just have to import them. I'll show that. For this collab, this is actually using materials, so I'm importing the mat card module. That's something I didn't really make clear, is that these behave a lot like test files, so you can import, you can add providers, you can override providers, all that good stuff. But yeah, so you could configure scenarios and possibly show them to a user if you didn't want them to end up in your production application. That's kind of a separate thing. But yeah, it's definitely catered towards a development environment. Yeah.
So I work on a library. The scenarios seem really interesting because we might build a component and want to show all the permutations of the options and features. So I'm interested in the documentation part a little bit more. Can you explain how that works with the iframe? What's loading in that iframe? How's that built?
Okay. Yeah, so the question was, can you explain more about the documentation? So I'll just show you, let me open up that file and code. It really is just a bunch of simple iframes that direct to URLs. So with Angular Playgrounds, we can build a production application with the sandboxes as the focus. So it works with service workers as well. So what you're seeing here is, in this documentation example, I have 3 iframes that go to this URL here, demo.angularplayground.it. And demo.angularplayground.it is this example, which is running Playground fully, built for production and then running in another server. In this case, this is just running on GitHub Pages. So we've basically built the application and pushed the Angular output into a docs file and just said Angular or GitHub Pages serve this docs file. And because it's all static, you can have it living alongside it. And so those iframes just direct to this URL. Does that answer your question?
Gets me closer to understand.
Okay. Yes. So the question is, does Angular Playground automatically look at the inputs and outputs of particular components to tailor a sandbox automatically for it? As of now, no. You know, right now these sandbox files are created manually. So you have to go in and create and add your own template. And a lot of the reason for that is because it has that flexibility where you can put whatever extra markup in a scenario that you want it to. One of the development things that we've got going on is integration with Angular CLI schematics. So you will be able to generate sandbox files. But I can't tell you whether or not we're going to read inputs, outputs of individual components, but perhaps. Yes.
Well, it seems to me that the sandbox wouldn't work unless you have a component already built. Right? So that defeats kind of the purpose that you indicated in the beginning. That is, if we wait until something is built, maybe it's not what we read about. So that's rational for the sandbox. But it's not functional unless it is built.
Okay. All right. So the comment was that the sandbox isn't functional until you actually have a component built alongside of it. So it kind of defeats the purpose of the scenario-driven development stuff. So I would say that when the component, you have to be building the components for your application anyway. And all we're doing is giving an easy environment to look at those components as you're developing on them. So as far as the scenario-driven development stuff goes, the fact that you have to create a component at that level is inevitable because you're working on the component at that level. What you don't need to create is the rest of the application, right? So I could just have the collapsed card component on its own, not even included in a module, and I could sandbox it using this tool without any other extra markup. So in that way, it gets around having to define a structure for your application. You can further that with a service. Perhaps I have an application with a service, or sorry, I have a component that relies on data from a service. Well, normally I'll have to create that service separately, add it to the provider's array of a module. But with this, I can just mock it out right in here like it's a test file, because that data has to live somewhere, and it has to be provided to that component.
Maybe one more question.
Yeah. Sorry? The wrap parameters. Oh, okay. So we actually worked on a routing issue, like not an issue, but a feature like a week ago. What you can do is actually just use the Angular routing test module. So because this so parallels what's going on with test files, you just put in the Angular routing test module and you treat it like a test, and you can mock all your routes and visit them in the sandbox as if it were just a test. All right.
Grab another round of applause.
All right, while Alex is coming over here and getting set up, I want to tell you a little bit about Alex. So know about him, I've seen him speak at conferences. But did you know he's an avid sailor? And along the whole sailing avenue, he was one of the lead authors for our new HTTP implementation. So sailing on the internet of APIs. And then if your boat ever gets stuck, that's probably also because he led the effort to build the new service worker. So when the caches are there, maybe blame some of that sailing background. So were those jokes terrible enough for you?
Yes. Hey guys. All right. So this is a pretty short talk that I put together that I call the theory of RxJS. And I've been to a lot of Rx talks at different Angular conferences by a lot of really good speakers. And they've all done a great job at kind of introducing Rx and introducing people to reactive programming and getting them started using the framework. And this is a talk really designed to complement that. For people who already know a little bit of Rx and you're using it in your own code, I want to do a bit of a deeper dive into how observables work, what they really are under the hood, and how to think about solving problems with them. So this code example here really illustrates for me the main point here, that although promises and observables are both asynchronous primitives, they're fundamentally different, and we can't just take an API call, get data that returns a promise, and change promise to observable and expect everything to continue working in exactly the same way that it did before. You really have to think about the meaning behind these things and how these two APIs are different. And we're going to approach this subject in 3 different parts. First, we're going to take a deeper look at asynchronous primitives in general and how observables kind of fit into the family there. Then we'll talk about Rx operators and some of the more interesting ones that we can use. And finally, we'll end with a practical look at a few of the patterns and anti-patterns that I've seen in real large-scale applications, both inside and outside of Google. So let's get started. In the very beginning, right, we have callbacks. Callbacks have been in JavaScript since the beginning. They really got popular with Node.js, with single-threaded asynchronous server-side programming. They're a very simple and a very lightweight way of waiting for something that's happening asynchronously. So here we're using the Node HTTP API, http.get. We pass in a URL. We pass in this callback function that'll get called whenever the result is available. And we're just console logging it. And what I want you to notice about this code snippet is the part marked here in red, right? This is the extent of our HTTP call in the code. And what you notice is that the callback, right, the definition of what to do next, is actually contained within the call itself. And this is a fundamental feature or a problem with callbacks. You have to define what to do next when you're initiating the operation, when you're in the process of making it. And this leads to the problem that we all know as callback hell, right? When you have this long chain of asynchronous things that need to happen, you have to declare the whole thing up front, right? One thing nested inside the other. And every step contains the callbacks of all the steps that happen after it. And that becomes really messy and really limiting very quickly. And that's why promises were so awesome, right? Because a promise lets us abstract that concept of waiting away, right? It's a reference to a value that may or may not be available yet. And it lets us perform the operation. In this case, we're making the same HTTP call using the fetch API and not worry about declaring what happens next, right? In fact, we can do that in a different file. We can pass that promise around. And eventually, we can say, OK, promise, go ahead and run this callback whenever the result's available. So the fundamental improvement that promises made was this decoupling of the initialization of an action, right? The initiation of an operation from what comes next. With promises, we can initiate operations and then worry about what happens. They abstract the idea of waiting, of expecting a future value, and they allow us to treat that expectation as a first-class object in our code. But they're not without their downsides, right? Promises only ever have one value in their entire life. That makes them really unsuitable for representing data that's changing over time. For example, a stream from a Firebase database, right? It's really hard to represent that with a promise. And they also go in one direction only. There's no way to actually cancel an in-progress operation if you only have a promise and are waiting for it to finish. And that's really where observables come in. Observables are like promises, and this is the only time in this talk you will hear me say that. Observables are like promises in the sense that they are also asynchronous primitives, and you can use them to solve the same problems. But those solutions are going to look different because observables under the hood are very different animals. So observables, as you probably have heard, they support multiple values, and you can cancel them. And those are useful distinctions. But the real thing that sets them apart is their laziness, right? A promise represents an action which has already begun, and we're waiting for it to complete. An observable, on the other hand, represents an operation that hasn't even started yet. So let's go ahead and define these two terms a little more rigorously. We're going to talk about computations, and computations can be performed eagerly or lazily. And if we state that a computation is eager, that means that it's evaluated as soon as it's defined, right? As soon as the JavaScript execution engine gets to a statement and runs that line. If a computation is done lazily, it means that it's not evaluated until it's needed, until the result is actually required. And that's an important distinction between many imperative and functional programming languages. Right? If you've done any functional programming, you probably know that computations generally are lazy. They don't happen until you need the result. But we can actually mimic this in an imperative language like JavaScript. And we do it using functions. So the top line here, this computation of eager result, adds the numbers 1 and 2. And as soon as the JavaScript interpreter gets to this, it'll compute the result 3 and store it in a variable. But just by wrapping that computation inside a function, now when the JavaScript interpreter gets here, it stows those instructions away and it doesn't actually run them. It's only when we call the function that we actually make that computation. So with that simple definition in mind, we can start building our mental model of how observables and promises are fundamentally different. So we're going to consider two axes here. On the vertical, on the left-hand side, we have eager versus lazy. And along the top horizontal, we have synchronous and asynchronous. Right, so what's an example of a value which is both synchronous, available right away, and eager, right, computed the moment it happens? Well, that's just any scalar value, a string, an object, a number, right? Anything that doesn't require us to compute it or wait for it. And we saw an example of synchronous and lazy, right? That's a function which returns a scalar. It's still synchronous. We call it, we have the result immediately. We don't have to wait. But it doesn't actually get computed until we call the function. So how about this asynchronous side? Well, it might surprise you a little bit, but promises are actually eager. When you have a promise, that means the operation that's computing the value is already in progress. Like when we call the fetch API, we get a promise back. The browser is already making that HTTP call, and it's going to return a result to us eventually. It's asynchronous, but eager. And that leaves us with one empty square, right? Any guesses? Not yet, right? You can actually have a function which returns a promise. That's both lazy, right? The promise doesn't get created. The operation doesn't start until you call the function. And it's asynchronous. We'll get our value back over time. And it turns out we do this all the time, right? This is exactly how a lot of services work. So we have this constant get data. It's a function that calls fetch. And whenever we call get data, an HTTP operation starts. We wait for our promise to resolve, and we get our data. And here's an important distinction, right? Every time we call this getData function, a new operation happens in the background. Because that computation is tied to the promise, And every time we call the function, we get a new promise. So this is a pattern that gets used over and over in services, right? We have API service. It's full of functions like get data. They return a promise to data. We do this all the time. So back to our model. Asynchronous and lazy is a function that returns a promise. Also in this box is the observable. And that is key, right? It's not a function that returns an observable. An observable is of itself an object that behaves like an asynchronous function. It represents an operation that could be performed and allows us to trigger that operation on demand whenever we want. And once we trigger that operation by subscribing, the values are returned asynchronously, just like a promise. So here's how we define such a thing, right? We're invoking the observable constructor. If you ever use the promise constructor, it's kind of similar. You pass it a function, and that function will get called every time someone subscribes to the observable. And inside that function, we get the subscriber, and we can do anything we like. Synchronous, asynchronous, doesn't matter. And when we want to push data to the subscriber, we call subscriber.next. So in this case, we're doing the same thing we did with our promise. We're wrapping the HTTP API. When we get our result callback, we push it to our subscriber. And the equivalent of calling the function then for an observable is subscribing. When we subscribe, we pass the callback that's going to get called whenever the observable emits. And if we subscribe a second time, it's like running the function a second time. We get another HTTP request made in the background. And unlike functions, we're not limited with unlike functions, we're not limited with an observable to returning just one result. We can emit as many times as we like. So here's an observable that just ticks away time every second using the setInterval API. And this example also illustrates another property of observables. They can actually understand when their subscriber is no longer interested in them. So from the function we pass in the constructor, we can return another function, and that gets called whenever the subscriber unsubscribes. There we can clear up or cancel any kind of long-running in-progress operations, HTTP calls. In this case, we're clearing up our timer. And that makes observables really powerful because they have back pressure. Right? They know when the UI is no longer interested in them. So getting back to our API service from the beginning, we've now learned that a promise and an observable have similar purposes, but they operate in very different ways. So it'd be rather strange to replace promise with observable in this getData function, because that's like declaring a function that returns something like a function that we would then call. Observables, remember, are by nature already very much like functions. So most likely, we'd want to expose this data observable directly. And it's safe to do that because unless someone subscribes to it, no calculation will actually happen. Right? This is a very cheap operation to create this thing. So now that we're armed with this mental model of observables, we can jump into operators. Operators are where the real power of Rx starts to show. So they are the observable equivalent of function composition, wrapping one function with another. An operator transforms an observable into another observable without subscribing to it. And the logic in the operator is also then lazy, right? It won't execute until the resulting observable is subscribed to. And Rx has over 100 of these things. I certainly don't know them off the top of my head. Some of them are pretty specialized. You only use them in very specific circumstances. I find most applications have about 20 different operators that they use on a regular basis. We're going to cover some of the more commonly used ones, particularly operators that focus on 3 use cases: transformation, projection, and combination. So the first set of operators I'm going to talk about are ones we're pretty much used to dealing with on arrays already. There are a few of them, but the most important 2 are map and filter. So map works identically to an array. It transforms one value to another using a projection function. Filter, on the other hand, uses a predicate to decide whether to include or exclude each individual value that's coming through. So here's how map works in code. We have this source observable, and we're going to initialize it with an array of numbers, 1, 2, and 3. So it'll emit the values 1, then 2, and then 3. And with the map operator, we're just going to transform each value by doubling it. And we get back this mapped observable And when you subscribe to that, it gives us 2, 4, 6, right? Very straightforward. But this map operation doesn't actually do anything to the source observable. It doesn't transform it in any way. And we can still subscribe directly to it and get back our original sequence, 1, 2, and 3. Right? It's very functional. So the second set of operators that I want to talk about are the projection operators. And this is where it starts to really get interesting, because these transform a value into a whole stream of other values. And that transformation can even be asynchronous, which makes these very useful operators. They're kind of the bread and butter of using Rx. So one common operation, for example, might be to take a stream of IDs and make an HTTP request to get data for each ID. And a very naive way of doing this, you see a lot of people starting out with Rx think, oh, okay, I know map. I'll just use map and map this value into an HTTP call. The problem is that map doesn't actually understand that the value you're transforming it to is an observable. So you end up with this thing that's an observable of data, right? And you see that in your IDE and you think, oh God, what happened? But this is actually somewhat common in Rx. We call this a higher order observable. And if you think about it, it makes sense. We've turned each ID into an asynchronous function that if we call it, if we subscribe to it, will get us the data for that ID. So what we really want to do, though, is then flatten those results down. We want something that will actually subscribe to that observable that we've created inside our map function and give us the values that come out. And that sounds relatively straightforward, but it's actually a vague requirement, right? There are a lot of different ways we could do this. Do we subscribe to every HTTP call at once and return the results in whatever order they come back? Do we wait for the first one to finish before we do the second one? You know, there's lots of different options there. And Rx has operators for each of these. So these are the projection operators. They all accomplish the same task of turning a higher order observable, right, an observable of observables, into a lower one, but each with a slightly different kind of behavior. Merge all, for example, will subscribe to all of them as they show up and combine all the results into a single stream without caring about what order they come back in. Concat all takes a slightly different approach. It subscribes to the first one, waits for it to finish, subscribes to the second one, etc. down the line. Switch all actually will unsubscribe from the previous observable that it's listening to whenever a new value shows up, right? So it's always going to subscribe to the latest one. And a little bit of trivia, for the longest time, I thought these were the 3 operators there are, but there's actually a 4th one in Rx. It's called exhaust, not exhaust all. And it's pretty exotic. I've only ever seen it used in one application. And what this does is ignore new values while the old subscription is still running. So it drops, it's kind of the opposite of switch all in that sense. So what does this look like in code? Well, starting from our source observable, we use map again, and we turn each ID into an observable that fetches the data for that ID. And then we call concat all. And that'll give us back a stream of data where each value is corresponds to the data for each ID. So we'll get the data for ID 1, then the data for ID 2, and the data for ID 3. And it turns out that this pattern is so prevalent in Rx, mapping to a higher order observable and concating or merging or switching back down, that Rx has shortcut operators for all of these. So we have the concat map operator, which does both steps at once, right? Transforms into an observable and flattens them back down again. But one mistake I see beginners in Rx use is they choose the same projection operator, and usually they pick merge map every time they want to do something asynchronous with an observable. And in fact, merge map is a pretty poor choice. I would argue that concat map should be your default asynchronous operator if you're going to use one of them. And why is that? Well, it's because most of the time when we work with source observables, they're in a particular order. We're processing events, click events from the DOM, form changes, etc. And we want to preserve that order even as we go through our asynchronous steps. And that's what concat map will do for us. It'll actually preserve that order as it subscribes to each inner observable. Switch map you should use when a new value makes everything you were doing before obsolete. The common example here is autocompleters. If you have an autocompleter and the user types the next character, you want to immediately stop with the query that you were doing previously and jump to subscribing to the new value. Form changes, right? Value events from forms, parameter observables from the router, also kind of similar. You really don't care if the user navigates to URL 1 and then 2. You want to get the data for 2. They've already left the page for 1. There's no need to hang around and fetch that. And merge map actually is not really needed that much in code. You really only use it when you're combining multiple streams of the similar type of data, and you don't really care what order they come in. And as I mentioned, exhaust map, nobody ever uses that one. So another issue with projection operators that I see is people needing to access both results, right? So this mapping operation, we make one HTTP request for /first, and then we make a second HTTP request that depends on the URL that came back in first. And if we were to subscribe to this, we would get a stream of the results of the second request. But what if we still wanted to access data from that first request, right? What if we wanted both of them? It turns out that all of these operators accept what's called a selector function, which can customize the output using both the inner value and the outer value. So for example, here we're using concat-map to do the same thing, but we're now passing it this function that takes first and second and returns an object that composes them both. And this is really useful when you're writing these long asynchronous flows, where you do something like start with the router parameters to get the current route ID, do a bunch of transformations on it, and at the very end, you want to post data back to the server using the same route ID, and it was all the way at the top, and you didn't really plummet through to the bottom. That gets really tricky to do normally, but with this pattern of passing the outer result through, it can be really easy. So the last set of operators that I want to cover are the combination operators. And these join together multiple input observables into a single stream. There are a few of them, but the two that I want to cover are combine latest and with latest from. So combine latest is a function, and it takes multiple observables as parameters. And the first thing it's going to do is it's going to wait for them to all emit once. And when they do that, it will emit, by default, an array with all of the values in it. And then as each observable emits, right, if any of them emit, it gives you a new array with the latest values that it's seen from all of them. So this is really useful when you want to do a database join, for example, where you're waiting on two different Firebase tables or two different Firebase queries, and you want to get the results from both of them at the same time. By default, it'll emit that array, but just like with concat-map, you can pass a selector function and customize exactly how you want the values to be combined. I find it's very useful to combine them into an object rather than receive them as an array, because then you're referencing, result dot, user and result dot account, and not, result bracket 0 bracket 1. And finally, the last operator we'll talk about is with latest from. This is a pretty cool little operator, and what it does is sideload another stream into the current operation that you're doing. So every time your main observable emits, it'll take the latest value it saw on your side observable and combine it, again, using the selector function, with the main value. So here we're watching a Firebase database, but we don't actually care when the Firebase database changes so much. We just want to merge it with the form values that the user's piping in. So whenever the form value changes, we just go and get whatever's in Firebase at that moment, merge it together, and emit the result. And this brings us to the final section that I wanted to cover, which is best practices. We're going to look at a handful of patterns and anti-patterns that I've seen in real applications. So first up is a pretty big anti-pattern, nesting subscriptions. Just don't do this. Rx works best when you start with an event that's emitted from the DOM or from a WebSocket or a database or something, go through a sequence of operators that transform that event into an update to your UI, and then a subscription that happens as close to the UI as possible. And what that does is allow cancellation and that back pressure of unsubscription to work properly, right? If the UI decides it's no longer interested in a value, if it unsubscribes, all the work that's being done to produce that value should come to a stop. Instead, what you can do is use projection operators to handle all these asynchronous steps and only subscribe at the end. So let's look at what this looks like in the wild. Here we're doing that same thing where we're making 2 HTTP requests, the second one depending on the first. But this time, whoever wrote this has put the subscribe for the second request inside the subscribe for the first. And they're also saving the values out into the component context. And this is kind of hard to read. You're not really sure when these events happen. We've introduced the state now where this .first can be populated and this .second is still waiting. This messes with cancellation. So if I cancel this outer observable, the inner one doesn't know about it. It introduces side effects in the middle of computation. It's just not a great way to deal with Rx. We can definitely clean this up using the concat map operator along with the selector function. And this is how you should write it. Now all the computation happens in the operators. It can be canceled by canceling the subscription. And we update our component UI in one fell swoop without these intermediate states where some things are loaded and others aren't. So let's look at a good pattern next. How to manage subscriptions. When components are destroyed, it's important that they clean up their subscriptions. Not only does that prevent memory leaks, but it also can prevent some really strange behavior when a component you thought was gone and off the screen, right, suddenly gets an event in one of its observables, maybe it was still listening to NGRX, and then it does something and triggers an update in the application. Unsubscribing is not actually that hard. You don't have to manually track subscriptions. We're going to look at a pattern which uses an onDestroy observable and an operator in order to do this more or less automatically. So the way this works is you first have to turn Angular's onDestroy lifecycle event into an observable that you can listen to. And to do this, we use a subject. So we create this onDestroy observable as a subject. And in the ng onDestroy event, we just next it a random value, right? So now we have this observable that's going to emit whenever the component's destroyed. So next, whenever this component does any kind of subscription, the last operator in our chain, right? Here we're making an HTTP call. We go through map, switch map, whatever. The last operator in the chain is this take until. And what take until does is subscribe until the signal observable emits, and then unsubscribe. And so what we're saying here is, as long as this component isn't destroyed, go for it. Receive values, whatever. But as soon as onDestroy emits, close up shop. So another anti-pattern that I frequently see is the use of side effects in operators. For example, in this code example, we have an API service with a getData function that gets data for a URL. And we're calling Angular's HTTP client, getting this URL, piping it through a map function. But we're abusing the map operator to pull this .data out, right, to set a property on our API service. This has a lot of negative effects on an application's architecture. It introduces state in places where you probably shouldn't have it. It also introduces a race condition. If someone calls getData on 2 different URLs and subscribes simultaneously, we're not sure which one's going to end up getting set on API service in the end. So instead, it's a much better idea to keep your operators pure and to use stateless services wherever you can. And state management tools like NGRX can really help you with that. And the last pattern I'd like to talk about is a pretty cool one, writing a custom operator. An operator in Rx is just a function which transforms one observable to another. You can do that by either subscribing and handling all the mechanics yourself, or you can simply wrap other operators. And you can achieve some pretty powerful and readable code by taking up all the complex business logic that you have in transforming values and wrapping them into kind of your own DSL that you build up. So we're going to do a really contrived case. We're going to write an operator that counts the number of characters in every string that comes through an observable. So as I mentioned, an operator is a function that transforms one observable to another. And you can see that's the inner function that we're returning. It's very customary to write custom operators as a function that you call to get the operator, and that allows you to pass arguments into them. So if you look at how map and filter and concat map are all written, they take arguments in and then return a closure that transforms one observable to another. And using the operator is as simple as calling it from pipe, just like any other operator you use in Rx. So that's just about it. We built a mental model of observables as asynchronous functions. We took a small tour of Rx's operator set, and we looked at some of the patterns and anti-patterns from real applications. So I hope you walk away from this tonight with a deeper understanding of Rx and how observables fit into the world of asynchronous JavaScript. Thank you very much.
So I'll introduce our next speaker here. I'm introducing Jason Aden, who actually helped out with both RxJS version 5.5, where you had those lettable operators introduced. So that's the first time we had this .pipe. And he's also helping out with the RxJS version 6 release. So if you get sick of tweeting at Ben Lesh, you can also tweet at Jason.
Thanks.
For both the blame and the thanks, right? The other thing that Jason is quite famous for is actually introducing the Angular package format, where I think it was at ngconf, we said, hey, we're giving everyone some guidance in terms of how to ship Angular libraries, because as developers, back when we first released Angular, a lot of people had components and libraries being consumed by 1 developer or 10 developers. And then it became 100 developers, then it became 1,000 developers. And so having sort of best practices was really important. And that's something we wanted to continue to revisit and continue to think about and help developers with. And so Jason is here to help us out with this.
Cool. Thanks, Steven. Hey, how's everybody doing? Oh, that bad, huh? Okay, so like Steven said, we did introduce Angular's package format back ngconf last year. I don't think we did a particularly great job of releasing any tools with it, since we didn't release any tools with it at all. Everybody's kind of left on their own to figure it out. So what we're going to do is kind of go through a little bit of the basics of what's required to distribute a library. I'm not going to go in much depth because there's other presentations on that, and you can read the spec that we've published. And then we're going to also hear from Alex Eagle, who there's kind of 2 ways that we can talk about publishing these libraries right now. One is with a community contribution library, and one is with a lot of work in Bazel. So let's get into it. All right, so why do we need this format? The main reason is for compatibility, right? You want your libraries to be compatible in any app that they go to. You want to be able to consume anybody. You want anybody to be able to consume them in their Angular apps. So you're building an app. It has a lot of dependencies on different libraries. They should all basically work together. You know, maybe you build flights, right? Google Flights, and you pull in a material library. It should just work. It should work with AOT. It should work in development. It should work in pretty much any environment. Shouldn't have to worry about, like, does it work with mobile, for instance? That should also just work out of the box. Who remembers jQuery UI plugins? Okay, at least a decent number, yes. So jQuery UI plugins, for instance, had a way that you would publish them, right? You'd wire them up to jQuery in a very specific way, and that would somewhat guarantee that they worked as expected, right? So for Angular libraries, now, like, the ecosystem's a little bit bigger. We have bundlers. We have Webpack, Clojure compiler, Rollup. There's also a lot of ways to optimize code. Things like Uglify. Clojure compiler, again, does optimization as well as bundling. Babili for ES 2015 sources. Butternut is another new optimizer that's out there. And you have a lot of tools, and you want your libraries to integrate with tools. CLI, the Angular Playground, Plunker, which just uses a script tag, StackBlitz, etc. You also have to be compatible with the Angular ecosystem. So that means being compatible with ahead of time compilation to get the benefits that we get there. You want TypeScript to be able to do auto completion and compile time checking, and you need to be able to publish to any platform. So there's a couple kind of key things here, I guess. Bundlers. Most bundlers, or, well, Webpack bundlers and Rollup and Clojure compiler are optimized for ECMAScript modules. So that's import and export statements, just like we use in TypeScript. Webpack accepts ES5 input. Closure compiler accepts ES 2015 input. It optimizes ES 2015 best. Rollup works with both, as long as you use ECMAScript modules. So there's a lot of sort of interplay between, you have to have the right format for the right tool, right? So this is what a ECMAScript module looks like in JavaScript import from, right, and export. And then this is what a down-leveled, this is what a down-leveled class looks like, right? Your down-leveled components, something like that. And then we have ECMAScript module format with ES 2015. So there's another output that you should be publishing, where the class keyword and things like fat arrow functions are not down leveled, right? So then optimizers, like who uses Uglify? Well, who uses Webpack and by default Uglify typically? Okay, so it only works with ES5. If you try to ship it ES 2015, it'll break when it sees a fat arrow function or the class keyword. Closure prefers ES 2015. And none of these optimizers can actually properly optimize UMD bundles. So previously, people, for the most part, published their libraries as UMD because they work in a browser. You can import them with like AMD modules, right? You can use AMD modules or RequireJS, System.js. They work on Node pretty well, but they can't be optimized well. And then we want to target tools. A lot of online tools use UMD format, right? They just import a script tag. So this is the UMD output. The Angular package format, we'd say you should publish a UMD. It's consumed by Node, and then it's consumed by like tools like Plunker and things like that. Plunker. Okay, so the Angular package format supports pretty much all of these major tools at once. And the key thing that we sort of started doing with that format was publishing multiple formats at the same time and keeping them, making sure they all work with all the existing tools relatively seamlessly. So the first thing would be the module resolution requirements. So modules are resolved like if you have a library, you distribute that library on, say, NPM, right? You've got a package.json file, and almost all package.json files have a main key in them, right? That's going to point to your main JavaScript source. So that's the one that Node.js reads by default. But if you publish a module key, then Webpack will first look at module. It'll look for that first, and if it doesn't have that, it'll fall back to main. We kind of recommend that you publish an ES 2015 version as well. So nothing by default is going to read that key, as far as I know. But you can configure Webpack if you want to like take ES 2015 sources and run them through Babel or something like that first. You can configure Webpack to read from the ES 2015. And then obviously TypeScript reads from the typings key. In terms of formats for each of these, main should be a UMD bundle. Module should be ECMAScript modules with ES5. ES 2015 is sort of obvious, and then typings is also obvious, right? D.TS. And this is an example of a package.json file that would be used for Angular package format. So there's really not anything like main, everything's basically in subfolders inside your distribution to NPM. So main would go into bundles, module into ESM5, and ES 2015 into an ESM 2015 folder. Typings is the only one that lives at the root, that reference to typings. And if you don't do that, there's certain scenarios where TypeScript will not read your typings correctly. So you actually have to do that. There's also tree shaking requirements built in, right? Like Uglify, you want Uglify to work well. So if you distribute as ESM, then you can use Webpack to produce a bundle that Uglify can tree shake. If you don't publish as ESM, if you only publish as like UMD, any modules in your library will not get tree shaken out, right? Uglify, it will have a really hard time, actually it can't, tree shake out unused code. So if you publish a large, say, math library and somebody only uses the square root function and they don't use anything else, you'd like all the rest of the library to go away, right? So you have to publish this ESM version in order for that to work. And then flat modules. So a flat module is basically you're taking all your bits and pieces. You're all told, make small code, like put your code into individual files, right? Then you kind of package it all up. Maybe you have an index file that re-exports everything. So a flat module basically takes all of your individual JavaScript or TypeScript files and puts them into one, right? And re-exports everything. So if we had a simple math library, add, we have an add module, a subtract module, and an index that just re-exports from both. If you were to publish this as, say, AMD, you're going to get a separate define. It's basically a separate module for each one of those files, right? And it's a lot of overhead. If you run it through a tool like Rollup, you end up with a much simpler file that takes the code from each of the individual modules and just produces one export. Okay, then the last tier kind of requirement that we're trying to satisfy is Angular's compiler, right? You want to be able to take that library and ahead of time compile it. So we have to publish metadata. It sits alongside your root DTS file. And your declaration, so if you're declaring directives in your library, whether or not you re-export those from like an index file, Angular still needs to see the symbol. And so some of those end up getting exported privately. If you've ever looked in some of the Angular distributions, or maybe in IntelliSense, you'll see a barred O, looks like a theta symbol. It's a little lowercase o with a line through it. Those are Angular's private symbols. Those have to be there, otherwise the compiler won't be able to take advantage of the directives that you might define in the library, or providers, or anything that you don't export yourself. The Angular compiler, if an ng module knows about it, it's going to re-export it for you in this private way. So, like taking a look at the Angular repo, we have the core DTS file, and right next to it the metadata file. Don't have to publish any summaries. Shouldn't publish summaries. And then inside you'll see, if you crack open some of these files, you'll see things like this, where certain symbols are re-exported with this little barred O inside of it, or in front of it. Okay, so that's just the quick summary on like the package format and what we're trying to distribute. Alex is going to come talk about some V6 plans.
Thanks.
Yes.
And Jason, we're still going to hand off again.
Yeah,
so
we're going to code him.
Yeah, you don't have to clap for him yet.
No.
I mean, don't. Oh. Okay. That's applause for both of us. So no more clapping the rest of the night. Okay, so hi. I found out about this talk yesterday, and I was like, hey, Jason, can I have a little slice of your talk to talk about what we're going to do with library packaging? And I think this is just coming together right now for Angular v6, which, as we said earlier, is scheduled for March, April-ish. And I'm on the CLI team officially, and so I want to talk about what we are hoping to do. So right now we're working on a build facade. And this is like one of the things we're working on most actively in the CLI. And what we can do with that is that when you run ng build, it can actually run one of several different tools. Today, the CLI is only exactly one stack. It always does the one thing that it knows how to do. We've picked, Webpack-based toolchain, and that's all you get. The idea with the facade is that we would be able to support more than one. So, for example, Jason is going to show this tool ng packager, which is a library, open source library, not maintained by our team. That's pretty popular. It allows you to create the format that Jason just described. And at the same time, our team has been working on using Bazel, which is the build tool that we use internally at Google. And so I could also imagine running ng build if I'm publishing a library. And we are working on a Bazel rule to create the same package format. And Igor and I have been working on this very actively, and it's almost finished. So I kind of want to give a preview, but just to repeat, we're planning to have these two options when we have the CLI for v6, and leaving it up to you to be able to choose which one of these you want to use. So ng Packager has the advantage that it already has a lot of community adoption. We just want to make it easier to use that underneath ng build instead of needing to use its own command line interface. We're going to work with the maintainer who we've been chatting with recently about making that possible, simply by having ng Packager implement the API of this build facade so that it can live underneath ng build. And at the same time, we're going to make the Bazel solution available. This is the one that we're currently moving Angular to. The entire Angular build is moving to Bazel. Angular Material is going to do this as well. And this packaging plugin that produces this package format is almost ready to merge. This is part of my project, which is called ABC. And if you want to find out more information generally about making Bazel a great build tool for Angular applications, this is the link, g.co/ng/ABC. This isn't a Bazel talk, but since I'm bringing it up, so I have to quickly explain why we're doing this. Why are we throwing this build tool out there that you probably aren't familiar with? It's mostly used historically for Java and C++ programs. Why do we want this in the JavaScript ecosystem? So there's 4 big reasons. Number 1 is incrementality. Super important. So when you make a change in your app, the amount of time you wait to rebuild should be proportional to what you changed. It should not rerun all of the steps. And because we have this incrementality, we are trying to get to a 2-second development round trip time, SLO, service level objective. And internally at Google, we are meeting this, and we track this number. This is how long our developers wait for ahead of time compilation, rebuilding the whole thing. The application is live in the browser, right? You should never wait more than 2 seconds for that to happen. Convergence is super important to our team, actually, because we have to support the Google internal toolchain, which currently is completely different from the toolchain that any of you are using. And so by making these two things the same, the things that are great about our toolchain you can have, and the things that are not great about our toolchain, we want to be able to bring in from the outside. So this is about doing open source the right way. It's hermetic, which sounds kind of like a dorky build system engineer will only care about this. But the fact that we can always reproduce any output given the same inputs means that you can actually execute some of the parts of the build on a remote machine. You can do parallelization. I have a 12-core machine. I'm using all the 12 cores. Bazel knows how to schedule this stuff because it can trust that the actions will produce the same thing every time you run them. This is also important because just this week we got a cool feature on Circle CI, which is that we have caching for our Bazel build, which means that every time a build kicks off, like if I push a new snapshot to my PR, it's only going to rebuild the things that were just affected by my change. We don't ever do a clean build on CI anymore. So you get that same 2-second turnaround time, depending on what change you make on your CI. And it's very composable. So the plugins for Bazel are meant to be interchangeable in the same way that Unix pipes are. So if this thing outputs a JS file, then any other rule that knows how to input a JS file, you can plug the two things together. You can make your own rules and plug them together. So it's easier to things. Oh, I waited too long. Your computer went to sleep because I talked for so long on this slide.
Oh.
Okay.
There it is.
I was just going to go ahead, but I couldn't talk through this slide, right? So I just want to briefly show what we're working on right now in the Angular project. So this is called ng package. This is a Bazel configuration file. So we load this thing from Angular and we call it. Basically, what's happening here is we're just describing. Okay, I'm going to have, the directory that I'm in has a package, and I point to the bits that we need to build the package format that Jason was describing, like our package JSON and a README and a license file, and some mappings that Webpack is going to that we're going to use for rollup, like the RxJS. And we might have several entry points, like things we can deep import. So you can import from @angular/core/testing, for example. So that has to be built into the core package. And each one of our packages has this file in it. So we don't have a giant configuration block at the top. It's more like inside of each package, we just describe, here's what's in this package. And we don't tell Bazel what to do. We just say, this is what's here. And it's up to it's the inside of the implementation of ng package to know what to do with that. So I ran this today. I made a change. So first of all, iBasil at the top is just the watch mode, like incremental Basil. So when I make a change, it'll just automatically rebuild the thing. Currently, it takes us 12 minutes to rebuild Angular because we have the shell script that is not incremental. And you can see here, it took me 5.8 seconds to rebuild the core package, including all of the different formats that are in there. This is roll up to ESM15 and ESM5 and UMD bundles, and like all this stuff happens in that time. So that's good for our productivity, and we think it could be good for you. I'm not going to you can't even read this, but what happens at the top here is that this is just a graph that Basil can produce that shows you the interdependencies under the covers. So this thing at the top is my rollup rule where I'm going to run, it's my package rule where I'm going to run rollup. And then that depends on these different Angular packages. So it depends on common and common/testing. Those are independently run through NGC, and those can be run in parallel. You can imagine that there are opportunities for parallelization in this graph. And RxJS is the thing that's next to TSC here. We actually compile RxJS from source. Eventually, two libraries that both use Basil, you don't need to publish a binary distribution in between them. They just one of them depends on the other as Basil rules, and then the whole thing is compiled from head. Okay.
Cool. We can clap for Alex. I will say for us on the Angular team, as we transition over to Basil, life is much better. So as this stuff continues to roll out, keep an eye out for it and try it. It can increase productivity and round trips on testing and things like that significantly. Okay, so a couple resources real quick. So one for packaging Angular. This is some links here. The original talk I did back in ngconf. The Angular package format version 5. That's the doc that we published that kind of says what it is and what it is. Doesn't tell you how to do it. Yuri S. Can't pronounce his last name. Did a really cool talk at NG Belgium. Is it BE? Yeah. Did a pretty cool talk there on hand coding this process. So he didn't use NG Packager. So for some of you that maybe can't rely on that for one reason or another, his talk's really good on just going through every single step and how to do it. And then Igor, for those of you that want more info on tree shaking, Igor did a good presentation somewhere. I can't remember where that was, but really cool presentation on tree shaking and what the caveats are, why your default Webpack config, if you're not using the Angular CLI, why your default Webpack config probably is preventing tree shaking. So check that out for the tree shaking side. All right, so libraries and helpers. We're going to go through NG Packager. This is a pretty cool library built by the community. There's also, for those of you that do Yeoman who want to just scaffold something out, you can use this generator Angular 2 library. It is just Angular, but he didn't change the name. So you can use that Yeoman generator. And then we're going to be using this Angular CLI library example, which is just a repo that I put together. And if anything's missed, you can go out here and take a look. And there's like 6 or so steps in here. And they're all relatively well described and some of the caveats. And we ran into a couple of oddities while sort of putting this together. So if you want to run through it, this describes some of those pretty well. All right, so I'm starting with a CLI library. The goal here is to have a library that we're calling ngx tabs lib. So it's just a library that has tabs and tab. It's only 2 components. But the idea is to have the library next to an app that would be the demo app for that library, right? And so the demo app is an Angular CLI app, and the whole thing is in the CLI. And you want to be able to develop the 2 of them in parallel, publish the library to NPM separately, and verify that the published thing works, right, in a real app. So the app is super simple. It just has these 2 tabs. And we're going to start from here, and we can just do ng serve just to get it started again. Looking through what's here, there's a libs directory in the root, and then inside of there, ngx tabs lib, and a module file that just pulls in the tabs component, tab component, right? Standard stuff. If we minimize this, there's also an apps directory, and inside of there is the demo app for this library. And in here, it's pulling in the library module through this import command. So right now we haven't done any real packaging, and this import command is working because you don't have to do the .. path, because in the root tsconfig, there's a reference to paths. Right now, I left my notes over here, so grab them. Okay, so the first thing that we want to do, right, is, or that I'm going to want to do here, is I want to drop this name. Like, we want to publish this library. It's not an npm scoped package or anything like that. I just want to drop this name, and I want to be able to import like this, because that's going to be the name of my package on npm, right? It should be npm install ngx tabs lib. So first thing I'm going to do is drop the namespace and come to the root tsconfig, and I can go into the paths here and rewrite the paths to ngx tabs lib, and that's going to live in libs /ngx tabs, right? So that'll just that will cause it to refer to this folder and then this folder, and it should work. It won't work until we do a reload TypeScript. But once we do reload TypeScript, that squiggly line goes away, and now the IDE knows how to get to our lib. All right. Okay, so that was the first thing. Now the library itself needs its own package.json file. So if you've ever seen a library where there's a ton of dev dependencies on npm, right? Doesn't really make sense, right? Why do you have dev dependencies as a published package? You shouldn't be publishing your big list of dev dependencies, right? So so we're going to create here a new file, package.json file. I'm going to copy it from the documentation that I wrote up here, but it's pretty small. Your library package.jsons are usually going to be pretty small. The peer dependency list is pretty short. So notice this is peer dependencies, not dev dependencies, right? Peer dependencies means that when you npm install this package, it won't auto install these, right? It relies on you to have them there. So if it's an Angular, it depends on Angular core and Angular common, but it won't auto install anything. It will depend on you to do the install of the right version for your application. And the name is ngx tabs lib. All right, so that'll be the first thing you need to do. Now I'm going to add, I have to stop this. I'm going to add ng packager. So there's a little issue here where this is called ng packager. And for now, we need to install the next version. And this is because he's in the middle of coming out with 2.0. If you use what's out there, what's not published as next, it doesn't work as well with Angular 5. Okay, so this one does work pretty well with Angular 5. There are still a couple of issues. It's in RC 11, I believe. So we add this. And then in your root package.json file, you're going to want to add, this already has a ton of scripts commands, but we're just going to add a new one for build lib. And this is going to run ng packager. And it takes a parameter, which is the project, or the P for project or package.json. I'm not sure what he's referring to, but you gotta point it to the right package.json for this library. So it's libs ngx tabs lib/package.json. Okay. So those two steps are sort of the initial configuration. We can now try to run this script, npm run build lib. We will get an error here. Hopefully it's the one I expected. Yes. Okay. So ng packager requires a little bit of setup, a little bit of configuration in its custom configuration in your library's package.json file. Okay. So if we come up to this package.json file, then the configuration that you need to do is add a custom property. Now it will delete this property when it actually publishes your library. So you don't have to worry about this. This is just, compile time info for ng packager. It will not be there in the distributed version of your package. But you pass in ng package, and then you have to tell it where the lib is, the library that you're trying to package. And specifically what the minimum requirement here is to define an entry file. So the entry file in this case is public API.ts. So if we look in public API.ts, all that it's going to do is re-export. It's just going to export the ngx tabs lib module. And we need to define a dist or destination, which is going to be dist/ngx tabs lib. Okay. So that's the minimum amount of configuration to be able to get this to work, I think. Okay, so now it's running successfully. One kind of cool thing here, it provides a little bit of info. You can see that it's noticing when things are imported and never used. It will end up dropping these things from the distributed version. Query list, there's a reference to query list, and it's saying we imported it, didn't use it, so it can help drop that. And if we go to anybody ever had this problem where VS Code doesn't realize that there's a new directory? It really is there. Just open a new copy of VS Code. Okay, so this is the dist directory that VS Code is not recognizing actually exists. And we have ngx tabs lib, okay? There's some problem with Mac OS file system or something. And so now we see the folders that I talked about earlier in the package format, bundles, ESM5, ESM 2015, and a package.json file that points to main module ES 2015 and typings. It also published the appropriate metadata file, and it published the public API. So let me close this one. Okay, so that's the minimum amount needed. It does work. It's a publishable library, which is pretty cool. And we should be able to verify that ng serve still works. Okay. Is your mic on, Alex? Okay. All right. So ng serve is still working. Okay. So on top of this, now we're not building the application against the distributed sources yet. All we did was build a library, and it works. And you could run an npm publish command and send it up to npm. But we're not verifying that the app actually runs against the distributed version of the library yet. So there's a little bit of configuration in order to make that work. And what we need to do, because this is a CLI project, we basically need to create a version of the app that points to a package.json file that points to the distributed library. So if you look in, may never really open this up too much, the Angular CLI JSON file, you'll see you scroll down here and there's this apps section. So one of the apps is demo. Down at the bottom, there's an app for the library. Okay, but if we take a look at the demo app, it has a property of tsconfig, which points to tsconfig app JSON. So if we come up to apps, we'll see inside of demo source tsconfig app JSON. Just get rid of this. And there's no real particularly important information in here, I guess, other than it's telling it that we're going to build this with ES 2015 modules. And it's extending from the root tsconfig, right? So we come back here, it's extending from this one. This is where most of your options are. So for the library, for the distributed library, what we want to be able to do is basically change paths to the distributed copy of the library. And we can do that by, I'm going to copy this one. Okay, so I'm going to copy this. I'm going to make a new tsconfig called packaged. And in this tsconfig, we can just exclude star.spec.ts. And that include is fine. Module is not CommonJS, it's ES 2015. We should be able to delete this target. And yes, it should extend that. Actually, sorry, I'm going to delete even more. My notes say I can delete all of this. So the only thing that I need to rewrite from this tsconfig is the paths here. So I'm going to rewrite paths. And this is going to go to dist. Okay, and then let's see, one more thing. We need to create inside of here, inside of the actual application. You also need another tsconfig. And this is tsconfig package JSON. It's going to point to the root packaged tsconfig. And we're going to change the dist directory dist apps demo packaged. And I think that's about it. Okay. So now the last thing to be able to do here that we would need to do is copy this entire application for this Angular CLI and produce a second one with a different name. So I'm going to call this packaged. The root, all the data is still the same other than maybe the outdir. We can publish this to packaged and the tsconfig packaged. Everything else can basically remain the same. And due to a strange bug that, if you want more details, read the notes in GitHub. The destination for your library for right now, the compiler is going to require that your library, instead of being built to dist, ends up getting built to the root. It's a little bit odd. Hopefully we can fix that pretty soon. But for right now, in order to make your app build against the library version, it has to be in the root, or it has to be npm installed. It's a little bit strange, but unfortunately that's how it is. Okay, that was a bunch of changes. We're going to rerun the build on the lib library. So that time it created ngx tabs lib in the root, And now we want to run ng build, say, we can try the prod version. If I did this wrong, it'll blow up. But this ng build, oh, I'm sorry, I did that wrong. I did do that wrong. Sorry, we're going to do ng build app equals demo packaged. So this name here, we're doing ng build demo packaged. It corresponds to the name that we gave it in the Angular CLI.json file. So this is not quite as fast as Bazel. It takes maybe 30 seconds. What's that? Yeah. Okay, it's done. Now I don't have to come up with a joke. That's good. Okay, so it finished. And the cool thing here is the app was built against the distribution version of ngx tabs lib, which means that we know that this works with AOT because we did a production build. And your setup still works. The environment still knows how to work with dev sources. If you just do ng serve, it will go against the dev sources. If you do this ng build prod against app demo packaged, it will build against the packaged version. Okay. I think that's about it for right this second. If you go to the repo, there's another section on private APIs, which might be kind of fun if you want to be able to mess with some of the names. You'll notice in here, this is a file that was generated by the library, and my tab component and my tabs component got exported with these little Bardo symbols inside of them, right? If you go through the example on the repo, you can customize those names so that you can use them. You can take one lib and keep something private to the library, but use it in another library that depends on it. So we do that between things like Angular Core and Angular Common, where there's private symbols. We customize the names. So this goes through how to do that as well. I think from me, that's about it. Okay, that is it. That's it for me. You want to do you want to show them Bazel? All right.
Do you also want to pull up the URL for your library? Well, we'll send out the slides as well.
Yeah, the slides will come out. It's under JSON Aden Angular CLI lib example.
Okay, so if you want to take a picture of that, if you're looking for that repo.
Yeah.
It'll also be on the live stream.
Should we do it? It works. Okay. So many of those steps, not every single one of them, the stuff that's specific to ng packager is for ng packager. Stuff about your TS configs you may or may not have to do. I don't think you have to do all of it, right? How much does Bazel the rule provide for you on the TS config side? Most of it.
Yeah. So under Bazel, you do the same thing we do at Google, which is there's one TS config at the root that just has the settings that you care about in your editor, and you don't do anything else with configuration files.
Yeah. Okay, so we're going to run
You can think of Bazel as removing most of your configuration files, because most of your configuration files are describing the shape of your application to each of your tools, and Bazel already knows the shape of your application, so it automatically configures the tools.
And this machine is not particularly fast. This is the first build,
so
but it's on the Angular repo.
Right, so we're actually building Angular Core's package here. This is the package that you download as that Angular/core and import from. We're building that thing, and then if you want to, you can make a change to
Oh, it's ready, yeah. All right. So we'll go ahead and.
Well, that was half a second because it was incremental. There was nothing to change.
Okay. We'll say this schema name is now old.
Yeah, so you can see here, it's using 3 cores on the machine. He's got 4 cores on the machine. It tries to leave 1 for you to use your editor. So it's parallelizing 3 ways that would be faster on the machine with more cores. You can see we're building the ES5 with ES modules. Most of the graph is parallelizable. They were running rollup on several things at once, and that one took 21 seconds. But that rebuilt the whole Angular core package.
Which normally is much longer.
And almost all the files are now included.
You promised 2 seconds.
Yeah, so 2 seconds. 2 seconds is for, okay, so this is not your development workflow.
Right.
You should not be publishing a package in order to see the change that you've just made in your code, right? So this is more like, oh, I have a horrible bug that is only reproducible in my package, and so I have to do this much longer development round trip. The 2 seconds is for 50th percentile, meaning like the average change you make or the median change would take 2 seconds. Some changes you make that change like you have a long string of libraries and you make a change that affects the API of one of them, it's going to need to retype check all the libraries down, and so there's a cascading rebuild, but that's atypical.
Also, like a lot of fine print.
Yeah, 50th percentile. So yeah, all the fine prints on the other 50th percent.
So what's the round trip for dev time? Right. I mean, dev time round trip. Right now, we've got dev time round trip.
So I guess I should
around the 2 seconds.
I mean, I'm selling
less.
something, so I should finish the sales pitch.
Sell it.
So with ABC, like this is Angular using it ourselves. This is not what you're going to do. You're not going to build Angular core unless you're a contributor. If you want to use Bazel for your own project, it is by the end of this week. I hope to make an announcement that it is feature complete for everything except code splitting loading, which we're still working on this quarter. And we're going to start with Rollup actually, which just this week got a code splitting feature. So what we already have working is a super fast development round trip, typically more like 1 second. The 2 seconds, the SLO should be independent of the size of your application, by the way. This works for very large applications like we have at Google. So you have a development server, you have karma testing, you have production bundling, you can do protractor end-to-end testing, and all of that stuff works. Yeah.
Thank you very much. Do we want to bring up back all the speakers and just do another full round of Q&A, answer any other questions, and then we'll let people get home. I know everyone here braved the rain, so thank you for making it through. We'll see if we can get more feedback going too. Get it? Feedback?
I get to hold the mic.
Sure. We have two.
You probably don't need one.
Well, okay. I'll leave it on then, I guess. Mine's feeding back a lot. Yeah. All right, questions? Yeah.
So you mentioned switch map for auto completion use cases where you have a stream of deliverables that emits the event each time there's a keystroke. Then on each of these keystrokes, you do a round trip with the code, and then you result in the map. Wouldn't it make more sense to just have, instead of canceling every time, have the most recent results in order to be emitted by whatever you would use instead of switching. So I'm typing the same typing Google, so GOO, so it sends 2 requests already. One of them might have returned Google already, but we've canceled that and we're doing a new one and waiting on that one.
Yeah, so
I don't know if it's on.
So the question is, wouldn't it be better for an autocompleter to keep those queries for old results running, because as each character you type, you're just narrowing down the set of results which might already be there. Yes, you could be intelligent about that. The problem is if the user hits the delete key and starts typing something else, then that model kind of falls apart. So you would have to do a lot more work to basically decide on the fly with every keystroke, is this something where I want to cancel what I've done before, or is this something where I want to keep going? Yeah, I imagine a sufficiently advanced autocompleter could do that.
I think throttling, if you use it as throttling.
Oh, yeah, definitely if you have the Rx operator debounce time also comes into play for a lot of autocompleters, where you wait until so many keystrokes, while the user is typing, you're not issuing requests spuriously, you're just waiting for them to kind of pause a little bit, and then you go out and get results from the network, and that tends to work a little better.
You compose it, switch map, and
Yeah, exactly.
Igor,
Yes, Stephen.
They've already been tweeted out by the Angular account, and they're posted to the meetup. For Alex, not for Grammar, Jason yet. Yeah.
Bazel we use is a hybrid app for Angular and AngularJS. AngularJS coding.
Yeah, so what does Bazel look like for an NG upgrade scenario where you have a mix of Angular and AngularJS? You can already develop an Angular app in TypeScript, an AngularJS app in TypeScript and use it with the TypeScript rules that come with Bazel. There's nothing I don't have anything in the example to do this yet. Obviously, internally at Google, we do that a lot, and so we do have Bazel support for doing it. It hasn't been on my roadmap yet for when that support would land. But honestly, I'm also not sure what stuff we are missing that you would need in order to do that, because there isn't a separate tool that we run as part of NG Upgrade. It's just that the library is present and we type check your usage of it. We run the Angular compiler on the Angular code. The AngularJS code just gets transpiled and loaded. So it's possible that all we need to do is just add an example.
Who's your question for? Alex.
Which one?
Happens every day.
Yeah. So, two parts of flatmap out as one of the operator.
Flatmap is the old name for merge map. They are identical.
And then also go into the schedulers. I mean, that's kind of the important part, how you can give a little bit more precision on how your objects are asynchronous or not quite as asynchronous.
I would love to talk about Rx schedulers. Unfortunately, I don't understand them at all. We would need to get Ben Lush in here for that, I think. Yeah, it's just a part of the API I haven't really worked with that much.
Take util on destroy nice. I would not use that all the time. Why is it just built in?
You should use that all the time. Oh, yeah. The question is take until on destroy. Why not use that all the time? You absolutely should. It would be nice if Angular gave you a lifecycle event in an observable form, and we're looking at doing things like that in future versions. Stay tuned.
I would also say look at using the async pipe, which manages the lifecycle of the subscriptions for you.
You mentioned the Bazel delivery schedule, the first announcement, coming to the end of this week. Does any of that include like CLI integration, or is that in the far future?
No. So the question is Bazel going to be in the CLI yet? We have not even thought about all of the stuff that we would need to do to make Bazel an option to run under Angular CLI. The team at Narwhal has done some prototyping with that. This is for applications, I should point out, right? So I already said, like, for developing a library and publishing it, this we are planning to release in Angular 6. At least as of now, it's still early in the 6 cycle, so no promises. I would anticipate sometime around the summer we will think more seriously about how when we have the build facade, how you could also develop an Angular application and still be using the CLI and under the covers using Bazel. Yeah, anything else to add there?
I would just comment generally on kind of the roadmap that all of our features end up going through, things like Bazel integration. First, we make it theoretically possible. Then we make it possible. Then we make it easy. And then we make it automatic. So I would say Bazel is somewhere in the first two.
Yeah. Not at all.
Yeah, I guess one quick thing to add there is that I think it's the main use case for Bazel is for a large application where the development turnaround time is too slow today, and the main use case for Angular CLI is to make a quick on-ramp for writing your first applications. So I think there will be some period of time where enterprise users will opt into using Bazel either directly or through something like Narwhal's NX, which already has experimental support for using Bazel. And that rolling it out to everybody will take more time as we make the ergonomics better.
Not a question directly about Angular, but what are your thoughts on Stencil.js?
Sure. So the question was, what do we think about Stencil.js? Sure. If anyone else wants to comment, go for it. Stencil.js is great. We are the Angular team. We spend most of our time thinking about Angular. So the Angular team in general, we think web components are an important part of the web story overall. Like we definitely believe in the web platform. That's why we have initiatives like Angular Elements that are going to make it easier to package and export your app or your components as web standards web components. So that is something we care about.
Between 1.64 and 6.5, the breaking change. Why is that?
There was a so the question was, why was there a breaking change between 1.64 and 1.65 of the CLI? There should not have been. If there was, file an issue and we will fix it. Yeah, no, we treat regressions, unintentional breaking changes very seriously, and they get prioritized very highly. So, what's that? Make sure you, in the issue, call it a regression. Yeah, talk to us afterwards. We'd love to take a look at that, make sure that's getting the appropriate attention. And then there was another question over here. I'm sorry, one more time? So Angular Elements, that project, that Angular Labs project, I think the intent is definitely to have support for that baked into things like the CLI, so that you can take an application and ship it as a library, ship it as an Angular element, whatever you need to do. That's the intent. It's a Angular Labs project, and I'm not going to guarantee any sort of outcomes. Rob might, though. If you care about Angular Elements, Rob Wormald loves them. All right, looks like there's one more question. Last question here.
Yes, under Bazel, there is only AOT. At Google, we only do AOT. We've never had just-in-time compiler. It's not even visible.
Can you repeat the question?
I'm sorry. The question was, is it AOT? The answer is yes. It always, under Bazel, everything is AOT.
All right, well, thank you all so much for coming. The next meetup, as I said, we're doing a joint meetup with GDG Silicon Valley and Modern Web, and that's on February 7th in, I think, just a couple weeks. So we're very excited about that. And we'll be around after if you have any questions. So thanks so much, everyone, for coming, and have a great night.